DFG Science TV, the start of nature, life in an open pit mine, from a lunar landscape to an ecosystem.
From rain simulation to GPS measurement, the researchers have used a large number of methods to explain the development of the Chicken Creek ecosystem. But how do the interactions between the different parts of the ecosystem make themselves visible? And how do the researchers evaluate the results for the entire catchment basin? To do this, the Research Association is building a virtual computer model. This makes the development of the ecosystem at Chicken Creek more understandable and more transparent. Anna Schneider and Thomas Maurer are working on this central computer model. Step by step, a three-dimensional image of the research area is created. The researchers can now view it from all perspectives. The interior of the site is also modeled here. The researchers already have quite a bit of information, but only a special method gives them a precise look into the subsurface. More than 100 electrodes have been pushed into the ground. They are used to measure the electrical resistance. This results in an image that shows the relationships between the subterranean clay layer and the soil surface. What's special about this is that it isn't done just once, but instead repeats itself constantly, over days and weeks. The ultimate plan is to measure for months and years. The purpose of the measurement is to detect very small differences. For example, in the event of a heavy rain shower, how quickly does the water seep into the soil along this line? How can we measure that? Well, that's easy because water affects the electrical resistance. Everyone knows that. Water is a very good conductor of electricity. The resistance drops in areas where water collects, and that's what we measure. On the computer model, cross-sections of certain areas show the internal structure of the site and the areas with groundwater. The virtual Chicken Creek will now grow in parallel with the development of the real Chicken Creek.
So what we still need to do is create this three-dimensional grid structure, as we call it, for different times. Using this three-dimensional representation, it will then also be possible to specify the volume of the change. We will then be able to say, for example, that at a certain place in the alluvial fan 1.5 cubic meters of material have been deposited, and using the information that we have, the overburden density, it is possible to deduce that this 1.5 cubic meters of material weighs 2.5 tons.
Anna Schneider and Thomas will still enter a great amount of information on the water, the soil and vegetation. So far, the experiments of the research team from BTU Cottbus, TU München and ETH Zurich have been successful. To learn even more about the formation of an ecosystem, the scientists would like to research further and continue the work in the Chicken Creek catchment basin. With this goal in mind, they get busy with office work. They're now writing a new proposal for future funding for their project, because there's still much to be researched in the catchment basin.
Visit DFG Science TV for more information. Awaken the researcher within you.